On behalf of Rovani College of Engineering and Technology, myself Justin Leo, Assistant Professor, Department of Mechanical Engineering, I welcome you all for this Basic Civil and Mechanical Engineering course. And the course code is B8252 for the regulation 2017. So in this video session, we'll be studying about the specialized subdisciplines in mechanical engineering. In Unit 1, Scope of Civil and Mechanical Engineering. So these are all the objectives for this basic civil and mechanical engineering. So the first objective is to impart basic knowledge on civil and mechanical engineering. And the second objective is to familiarize the materials and measurements used in civil engineering, and to provide the exposure on the fundamental elements of civil engineering structures, and to enable the students to distinguish the components and working principle of power plant units, internal combustion engines, and refrigeration and air conditioning system. So coming to the syllabus of this first unit, you have here the first part as the overview of civil engineering, and the second part is the overview of mechanical engineering. So in that we'll be studying about the mechanical engineering contribution to the welfare of the society and the specialized subdisciplines in mechanical engineering, which we'll be studying in detail in this video session, and production, automobile, energy engineering, and interdisciplinary concepts in civil and mechanical engineering. So these are all the textbooks and reference books for this basic civil and mechanical engineering course, and these are all the course outcomes. So the students, after completion of the course, they will be able to explain the basic concepts of civil and mechanical engineering from Unit 1, and from Unit 2 the students will be able to select the materials and measurement techniques used in civil engineering. And from the Unit 3, the students will be able to summarize the fundamental building components and civil engineering structures. And from Unit 4, the students will be able to illustrate various IC engines and power plant systems and subsystems with layout. And from Unit 5, the students will be able to experiment with the typical domestic refrigerator and different types of room air conditioner. So, introduction to specialized subdisciplines in mechanical engineering. So, the field of mechanical engineering can be taught as a collection of many mechanical engineering science disciplines. And several of these disciplines, which are typically taught at the undergraduate level, are listed in upcoming slides. And that also includes a brief explanation and most common application of each. So some of these subdisciplines are almost unique to mechanical engineering, while others may be the combination of mechanical engineering and one or more other disciplines. And most work that a mechanical engineer does uses skills and techniques for several of these subdisciplines, as well as specialized subdisciplines. And the specialized subdisciplines as used in this slides are more likely to be the subject of graduate studies or on-the-job training than undergraduate research. So specialized subdisciplines in mechanical engineering. So there are several specialized subdisciplines are discussed here. So the first one is mechanics. So mechanics is in the most general sense the study of forces and their effect upon matter. So So typically, engineering mechanics is used to analyze and predict the acceleration and deformation, both for elastic and plastic of objects which are subjected to forces, also called loads or stresses. So this mechanics also has some few subdisciplines which all listed out here. So first subdiscipline of mechanics is the statics. So what is statics? So statics is the study of non-moving bodies under known loads and how forces affect static bodies. And the second subdiscipline of mechanics is dynamics. So dynamics is the study of how forces affect the moving bodies. And this includes kinematics, that is movement, velocity and acceleration, and kinetics, that is about forces and resulting acceleration. And the third subdiscipline of mechanics is mechanics of materials. So this is nothing but the study of how different material would deform under various types of stresses. And the next one is the fluid mechanics. So this is nothing but the study of how fluids would react when subjected to forces. And the next one is the kinematics, which is a subdiscipline of mechanics. So this involves the study of motions of bodies and the systems while ignoring the forces that would cause the motion. And this kinematics is mostly used in design and analysis of mechanisms. And the final subdiscipline of mechanics is continuum mechanics. So this is a method of applying mechanics that assumes that objects are continuous, so rather than discrete. And common applications of mechanics. So mechanical engineers normally use mechanics in design or analysis phases of engineering. And if the engineering projects based on the design of a vehicle, statics might be employed to design the frame of the vehicle. So in order to evaluate where the stresses will be most intense. And dynamics might be used when designing the car's engine in order to evaluate the forces acting in the pistons and cams as the engine cycles. So mechanics of materials might be used to choose appropriate materials for the frame and engine. And fluid mechanics might be used to design a ventilation system for the vehicle or to design the intake system for the engine. So the second specialized subdisciplines in mechanical engineering is mechatronics and robotics. So what is mechatronics? Mechatronics is nothing but it is a combination of mechanics and electronics. So this mechatronics is an interdisciplinary branch of mechanical engineering, electrical engineering, and software engineering. And this is concerned with integrating electrical and mechanical engineering so as to create an hybrid systems. And in this way, machines can be automated through the use of electric motors, servo mechanisms, and other electrical systems. And in conjunction with special softwares. And see, for example, a mechatronic system. Example for a mechatronic system is a CD-ROM drive. So mechanical system open and close the drive and spin the CD and move the laser. while in optical system reads the data on the CD and converts into bits. So this is a common example of a mechatronic system. And integrated software controls the process and communicates the content of the CD to the computer. And as far as robotics is concerned, it is an application of mechatronics to create robots. And these robots, you would be aware that it's been used in industry to perform tasks which may be dangerous, unpleasant, or repetitive actions. So these robots may be of any shape and size, but these robots are all programmed and would interact physically with the world. In order to create a robot, an engineer typically employs this kinematics, that is to determine the robot's range of motion, and mechanics, that is to determine the stresses within the robot. And these robots are normally used extensively in industrial engineering. So common applications of mechatronics and robotics. And these robots are widely used in industrial engineering, and they allow business to save money on labor, and they perform tasks that are very dangerous or very precise for humans to perform them economically. And to ensure better quality, it has been used. So many companies employ assembly lines of robots, and most probably in automotive industries. So the third specialized subdisciplines in mechanical engineering is the structural analysis, and it is a branch of mechanical engineering and also civil engineering devoted to examining why and how objects fail, and also to fix the objects and the performance. So this structural failure normally occurs in two modes, general modes. The first is the static failure, and the second one is the fatigue failure. So when the static structural failure occurs, upon being loaded, the object being analyzed either breaks or it is deformed plastically, so depending on the criterion for failure. And fatigue failure occurs when an object is subjected to repeated loadings and unloading cycles, and this object would fail. So common applications of structural analysis. So this is often used by mechanical engineers after a failure has occurred, or when designing to prevent failure. So online documents normally were used by these engineers, and books such as those published by ASM to aid them in determining the type of failure and possible causes. And the fourth specialized subdiscipline in mechanical engineering is thermodynamics and thermoscience. So this is an applied science used in several branches of engineering, including mechanical and chemical engineering. And thermodynamics is the study of energy, its use and transformation through a system. So engineering dynamics is concerned with changing energy from one form to another. So for example, automotive engines that would convert chemical energy from the fuel into heat energy and then into mechanical work, so that eventually turns the wheels of the automobile. So these are all the common applications of thermodynamics and thermoscience. So thermodynamics principles are used by mechanical engineers mostly in the fields of heat transfer, thermofluids, and energy conversions. And mechanical engineers use thermoscience to design engines and power plants, heating, ventilations, and air conditioning systems, heat exchangers, heat sinks, radiators, refrigeration, insulations, etc. So the fifth specialized subdisciplines in mechanical engineering is design and drafting. So this is also called as a technical drawing, and it is a mean uh, by which a mechanical engineer would design the products and create instructions for manufacturing the parts. So this drafting or technical drawing can be computer model, or it may be drawn by hand, which is a schematic showing all the dimensions that are required for manufacturing of the part, and as well as it is an assembly notes and a list of required materials and other pertinent information. So this mechanical engineer or a skilled worker who creates a technical drawing may be referred as a drafter or a draftsman. And this drafting has normally historically been a two-dimensional process, but computer-aided design programs now allow the designer to create even in 3 dimensions. So coming to the common applications of design and drafting, it's used in nearly every subdisciplines of mechanical engineering and also by many other branches of engineering and architecture. And 3-dimensional models created using CAD softwares are commonly used in FEA, finite element analysis, and CFD, that is computational fluid dynamics. So with this, we come to an end with this video session of the first unit. So thank you and have a